Hola, hola a todos, saludos. Hello everyone. Por favor, escriban por el chat si se escucha y si se ve bien. Excelente, excelente. Pues muy bien, vamos a dar inicio a esta sesión. Gracias a todos por mantenerse en sintonía, por mantenerse al pendiente. Entonces continuamos con nuestro querido Karan Balkar, quien nos acompaña. Vean el alcance que tiene JConf Dominicana, señora. Nos acompaña desde la India, ¿no? Y nos va a hablar sobre, bueno, su sesión consistirá en hablarnos sobre Demystifying the Java Flight Recorder API. So here we have Karan Balkar, who's a mobile application developer, primarily working on Android for the past 5 years, also have worked with augmented reality and virtual reality. He's going to be sharing with us Demystifying the Java Flight Recorder. In a couple of minutes, he's going to start sharing his screen. But before we want to thank our sponsors that have made this possible, queremos agradecer a nuestros sponsors que han hecho esto posible. Recordando Aplaude Studios, Avatar Tech, Higgs, la Pontificia Universidad Católica Madre y Maestra, el Comité de Estudiantes de Ingeniería en Sistemas y Computación, y JetBrains. So, Karen, the scenario is all yours.
Okay, so thank you so much. Let me just share my screen. Okay, so first of all, good morning and hello everyone. Thank you so much for joining this session. So my name is Karan and today I'll be talking about demystifying the Java Flight Recorder API and how one can actually start using this in their own projects. So before I begin with the presentation, a huge thank you to the entire team of JConf Dominicana 2022 for giving me this opportunity to present my talk. So first of all, thank you so much and really well done. So moving on to the next slide now, a brief background about me, although the host gave an idea, but yes, I would like to touch upon a few things. So yes, I am primarily working as an Android developer now for the past 5+ years, and I've been mainly involved in developing B2C and B2B based applications. I've been also been doing applications around AI, AR, and VR. And if you ask me, like, what apart from technology do you do? So apart from technology, I also love writing poems. I like to travel to different places across the globe and meet new people. So that's about me in a nutshell. Now, for those of you who have heard about the Java Flight Recorder, or for those of you who are not aware, I will just like to give you a slight background. Now, the Java or the JDK Flight Recorder was basically an event recorder that was introduced way back into in the Java virtual machine. So this was a part of the JEP, Java Enhancement Proposal number 328, and there is where it all started. Where the whole idea was to build something as an event recorder which would help to record events in the Java virtual machine, and that is when they introduced the JDK Flight Recorder. The main idea, or the main reason of introducing this was to perform certain tasks like garbage collection, black box analysis, profiling, etc. And it was later open sourced in the year 2018. So it was a part of the OpenJDK 11 to begin with, and then it moved on to the Oracle-based Java, as well as to JRocket, where it was a part as a commercial feature. Now, it is said that the Java Flight Recorder has almost no performance overhead. Now, there is a slight disclaimer here. So under default settings, so if you're operating under default or the standard settings, the Java Flight Recorder API has less than, say, 1% of performance overhead. But if you're using the Java Flight Recorder in case of very applications which are slowly running, or in case of the environment, if it's not a production environment, then it is observed that the performance overhead would be significantly more. So here, based on the number of tests which has been conducted previously and the number of analysis that have been done, it is said that yes, in default settings it has almost no, or you can say negligible performance overhead. Now, the main reason of using the Java flight recorder is to obtain the flight recordings, and the analysis and visualization of these recordings is done using the Java mission control. Now, the Java mission control is also something that I think most of you might have seen in the past or might have actually used as well. Now, the main idea of this Java mission control is to provide a set of tools, an advanced set of tools for doing certain tasks like monitoring, profiling of, and also troubleshooting of Java applications. Now, what does this do is basically it provides you a graphical user interface, and what it takes as an input is basically a Java flight recording file, which has an extension .jfr. And once you provide this input to the tool, it basically gives you a full interface showing all the parameters, like for example CPU usage, heap usage of your application. Now, there is also an open source version available of this tool, which I have mentioned in the link below. So for those of you who would like to try it out, you can also view it as well by visiting the link below. Now, coming to the main topic of our presentation is that how does one actually get started running the Java flight recorder, and how to basically write your first program using the Java flight recorder API. Now, here there are two main approaches. Now, the first approach is called as a command line approach, where you have already you have the JCMD tool, which is a part of your Java installation directory, and using this tool you can also start using the Java flight recorder. So all you need to do is run a particular command, say JCMD followed by the process ID of your application, followed by the command that you would like to do. So in this case I have used jfr.start, which basically signifies to start the recording. Then also you need to specify the duration, like how much duration you need to the recording to happen, and followed by the file name. So in this case, what this command would do is that it would run the recording, to start the recording for a duration of 60 seconds, and that recording would be stored in a file named, say, myrecording.jfr. Now this is maybe a more standard approach, but the approach that we would be talking about in this session is more on the second one, which is basically using the Java flight recorder API and using or creating a Java program or an agent. So in this case, all the difference in the command is that we would not be using the JCMD tool here, but instead we would be creating our own Java class, and you would use the command java-xx start flight recording, specify the file name, and again you specify the name of the Java class. Now here I would like to highlight is that the Java flight recorder is basically a commercial tool. So it is ideally it is to be used only in production environments. But if you like to leverage it in a, say, maybe in a staging or in a development kind of an environment, you'll have to basically unlock the commercial features. So here is where you would need to add an additional parameter, say unlock commercial features, and then provide the rest of the inputs as it is done in the first command. So a quick pause here. So what I'll try to do is that I will show you how basically one can get started. So I have, in the interest of time, I have already implemented a small application where I have demonstrated this. So let me play it as a part of my video. So here you can see that I have a class called hello, which extends the event class, which is a built-in class of the flight recorder API. This has certain annotations. I'll be talking about annotations in the subsequent slides, and it has a optional message. So this message is something that we would be logging in. You can see that there is an event object which has been created, and there are two functions which have been invoked, event.begin and event.commit. So I'll be talking about this. Now, how does one go about running this application? So as I mentioned, one can run it using either the JCMD command directly, or one can use the editor built-in functionality. So in this case, I've been using Eclipse, so you can actually provide the arguments and run this. So once the program is running, you can see that already the recording has started. Now what this is basically going to do, the output of this is going to basically it is going to create a log file, a recording file, which is a JFR file, and one can actually view the contents of this by going into the command prompt and running another command, so by which you can actually view the contents of this recording file. So let me try to demonstrate that. So you can see, once you obtain the contents of the recording file, here I would like to now highlight what exactly it means. So you can see there is a start time, there is a duration, there is a message. So this message is basically the message that we passed on as a part of our program. And you can also see something called as a stack trace, where it gives you an idea about a possible idea where if there is an error or a case of an issue, it will also show what is the line number where the issue is occurred. So in this case, it's basically simple, where I've basically logged a simple message saying hello flight recorder. Now going back to the presentation. Now I talked about basically two things first. So I talked about annotations. Now what are these annotations? So this was a simple program where you had just one class, and but in case of a live application, you would be recording multiple events. So how do you distinguish between these events? So for that, you need to use annotations. Now annotation basically has like there are a lot of annotations, like for example name, label. So name basically will be the name of your event, so it has to be a unique name. The label will be giving more description about that event, and you have to have basically a certain parameter called, or the message that you will log in would be recording. It also has to be an annotated. And you can see that we are using two functions here, begin and commit. So the begin basically is it's as the name suggests, is going to start the recording, and the commit basically would stop the recording and would also be writing the the output to a file, which is going to be your recording file. So this is how easy it is, that how one can easily start using the JFR API. Now, moving on to the next slide, I talked about certain annotations, and these are basically nothing but metadata, you can say. So how do you actually provide more information about the events? By this is done using annotations. So you can see there are a lot of annotations like description, label annotations, which help you to give more information, or more additional information about the event. There's also an annotation called category, which enable you to associate maybe one or more categories with an event. So if you are working in an application where there are multiple events, might have to categorize it into different ways. So there the category annotation can be used. And if you want to specify, say, more than one category, you can also use a comma separated list of strings, which is surrounded by normal braces. So this is how easy it is to get started, or if in case you are using multiple events in the application. Now, coming to the next slide. Now, as you saw in the previous demonstration, that I actually wanted to view the contents of the recording file. Now, definitely, the recording file will contain data which is machine data, which we will not be able to read, as humans will not be able to understand. So therefore, we need to have a tool or something that would help to interact with these files. So how do we do that? Is something that with already Java provides, which is called as the JFR tool. And the JFR tool is again used to summarize and output all the information stored in this the Java recording files into a more human readable format. So then we can actually understand what is the content of what is the content stored in this recording file. So let's see how that is used. So for using the JFR tool, all we need to do is that you can use a simple command where you specify the parameter print, and so you write JFR print followed by the name of your event. So in this case, my event name was com.app.hello flight recorder, followed by the name of the recording file which got created after I run the program. So here you can see that the output of this would be basically something like the screenshot, where you can see the start time, the duration, the message that we actually logged in, the event thread, which is the main thread, and the stack trace. So this is basically going to give you more information, which is more or less readable to us and to us developers, and this could actually give us an idea about what exactly is going on when the event was recorded. So this is how easy it is to get started with the JFR tool. Now the question that you might be asking is that, first of all, why do we actually have to use this API, or why do we need to use the Java Flight Recorder API? Now typically in as developers, we all face issues that whenever our application goes into production, and whenever there is an issue that occurs, one of the most common things that we do, or the most the frequent approaches that we take is by using logs. So we try to analyze the logs to find out what is the issue, what is the problem. And but the question is logging actually the most effective strategies out there? So if you had to ask me whether logging is the most effective production strategy, I would say might be, might not be, but it depends on how you use it. So, and especially if you're using logging, you have to also take into consideration so many factors, like the size of the log files, then how would you actually manage them, the backup, etc. And the question that comes actually is that, is it actually safe to debug in production? So this is some of the reasons that you need to think while using the Java Flight Recorder API, and how it can be useful is something that we'll also talk about in the next slide. Now, prior to the Java Flight Recorder API, I think most of us are also familiar with something called as a Java util login. Now, it is said that this kind of a framework, Java util login, although it was introduced way back in JDK 1.6, but now slowly it is actually reaching the end of the road. Now, why do they say this? Because one of the limitations, or one of the key limitations, is its inability to have per web application login. Now, especially in case of popular application servers like Tomcat, it is observed that this particular logging framework is not used as a as a standard or as a general implementation. Moreover, actually they use a customized version of the logging framework, and the lack of the buffered handler implementation also has a significant impact on the performance. So the Java util login, although there are many frameworks that support it, but in case of Java Flight Recorder API, it does not provide more in the other logging frameworks. And the main one of the main reason of this not picking up is that it does not provide more information regarding the context in which the event occurs. So if someone wants to know more about the information about where the what happened actually about when the log was done or when the log was written, so that information will not be provided by this java util.login. So there is one limitation over there. Now, to understand the differences between JFR and JUL, so I have basically created this table. So the JFR basically, yes, it provides more contextual information because using metadata, like I mentioned, using the event metadata, you can actually provide more information about the events. And in this case, in case of the JUL, yes, loggers are responsible for capturing the events and then passing them to the appropriate appender. So we use file appenders and those things where we actually log our messages. On the other hand, the Java Flight Recorder API, as I mentioned, requires a commercial license to be used, whereas if you're using JUL, you do not require any commercial license as such. In case of a Java Flight Recorder, you can also do visualization. So the recording files can be visualized, and you can do some better analysis and come up with, I would say, better approaches or something like that. But in case of JUL, you have no visualization support as such. Customization is possible in both cases, where you can customize your events, you can create more customized events, and in case of logs also you can use that using formatters. But the main difference here is that in case of Java Flight Recorder API, although it may take you some time to get it set it up in your project, but in the long run, in future, actually it can save you a lot of time. Whereas in case of a JUL, although it is easier to implement, you can actually get started using the JUL very quickly in your project, but then in the long run it may not be that useful for you. So that is basically one of the key differences between the JFR and the JUL. Now moving on to the next slide, so let's take a very simple example or a practical example of where the Java Flight Recorder API can be used. So for this, I'll be actually demonstrating a very simple example that I've used in one of my sample projects to basically identify the slow running SQL queries. So now this is the common scenario where we need to find out why is a query running slow, or what could be the problem with our backend queries. So for this, actually I have written a query. So this is one of the queries that I had used, where I have performed basically a join on two tables. So it's involving two tables, say a product and a sales order table. And you can see there is a inner join being performed over here. Now assuming the columns are basically indexed, still this kind of a query will not be more it will actually result in a performance bottleneck. Why that is so? Because even though there is an inner join and even if the columns are indexed, there is an or condition here that would basically create a lot of problems. So this would actually create a lot of performance issues, especially when if the columns are too many or if there is a lot of data in the tables. So here the performance would not be as expected. So definitely this is basically going to be a problem for us developers to do the performance tuning of this kind of a query. But if I had to replace this query with something like this, where instead of the or, basically I have replaced the or now with the union, and basically the same inner join has been performed on the same tables. Now in this case, it will be observed that yes, this kind of a query will basically have a better performance, because in this case we have used a union which helps you to remove duplicates, and that will ensure that whatever result you have obtained is basically it's a valid one, and it is basically returning the actual proper data with less time. So this is basically how one can actually identify the slow running SQL queries. But then how the Java Flight Recorder API is going to be used here is something that I'll be talking about next. So let's say I have a simple use case where I have basically done some basic database operations, like for example, inserting and fetching of records. So here what I've done is that I have created a simple SQL analyzer kind of a program where basically I have inserted say more than 15k records. And here you can see that based on the recording file that I've tried to understand and analyze, I see that the duration of this particular task took me just 45.9 seconds, which means that this is the amount of time it required to insert these kind of records. So this is going to give me an idea, like definitely there is a lot of time, and this definitely can be reduced, because if I want to improve the performance of my application, I need to make sure that this time is considerably less rather than more. So this kind of activity can help you to identify your slow running queries. Now in case of fetching as well, so let's say if you're using queries that are used to fetch a particular record, and in that case, if suppose if the record is existing, so there you can see the duration here is basically 59.2 milliseconds for a particular record which is existing. Whereas if the record is say not existing, then the same duration goes up to 109 milliseconds. So definitely you can see that there is a difference of time, and here is where you could identify and try to reduce this gap, because definitely you would not like this much time to even affect your application in production. So these are common use cases that you can use in your projects to basically use a Java Flight Recorder API and try to analyze this kind of queries to identify whether which queries are actually running slow. Now moving on to the next slide. Now it is said that JFR is not just about the event recording, but it has a lot more to offer. So there are certain features like dynamic events, custom annotations, periodic events, and event streaming API. So there are a lot of features that JFR actually offers, but today actually I'll be focusing on the fourth one, which is basically the event streaming API. Now what is the use of the event streaming API? The event streaming API, first of all, is to monitor all your HTTP calls which are going to happen on the network. For example, if you're having, say, a Spring Boot or any application, a web application or a Spring MVC based application where you're doing or performing HTTP calls over the network, then this kind of an API can be useful. So how it can be done is that the first step, of course, is to if this is for you to create your own class. So you create your own class which will extend again the event class of the Java Flight Recorder, and you could specify a unique name for your event. So in this case, I have specified a unique name for my event, and you will define some metadata. So in this case, I have defined a metadata called query parameters. So my task here is to get the query parameters of the URL. So moving on to the next slide. So once you have defined the custom event, you could actually go about creating your RESTful endpoint. So in this case, assuming you are familiar with Spring Boot, so in this case, what I've done is that I have basically created a simple RESTful endpoint, specified the request parameters for that, and what I've done is that inside this I have actually created an object of my event class which I've written before, and use the same methods begin and commit to basically start and stop the recording. So what this would do is that whenever the endpoint is basically invoked, it will try to start the recording, get the query parameters from the URL, and then store that maybe in the as a part of the recording. And once it is committed, once the commit has been successful. So this example basically, although it may sound simple, but then if you're performing certain operations, certain critical or memory intensive operations in your RESTful endpoint, then this recording or this particular recording obtained will help you to analyze why those particular memory intensive tasks are taking time. So this example is basically created for that purpose. Now in order to basically subscribe to events, you need to basically also understand, like this API provides a class called as an event stream class. So this event stream class has it basically helps to subscribe to events. So what will happen is that when you actually subscribe to the event that you have created, which is basically the HTTP request event, you can actually specify certain conditions. So if for example, you can say that if the request takes say more than say 2500 milliseconds, or if you can say any particular threshold, then you try to basically log or try to basically analyze what could be the problem. So here you can do as per your requirement, where you can actually put in some conditions based on your requirement, and try to analyze what could be the problem in case of if the case of whether it's taking time for the API to respond. So this is how useful this kind of an API can be. And in order to basically run this, all you need to do is that as you're running the Spring Boot application, you could just specify the start flight recording parameter, and pass the name of the jar file, or the final output of your Spring Boot no, the output of the Spring Boot project. And then all it would do is that it would run that basically in your console, and it would basically start recording this and storing it in a recording file. So this is how easy it is to actually get started with that. Now, moving on to the next slide. Before that, I wanted to highlight that all the sample code and the slide decks have been I have actually provided in the link below. So, and these programs have been tested and compiled using the JDK 16. I've used Eclipse for development as well. So I'll take a quick pause here, and I will go back to my solution video where I'll be showcasing how the flight recorder event streaming API is working. So I'll just scroll a little. Yes. So once this part is done, so let's say, for example, I want to now basically try to monitor my HTTP logs. So here, as I mentioned, I have created a sample endpoint. So this sample endpoint, say it's called greeting. So this is basically try to monitor the HTTP calls. So here I have created an object of the custom class which I have mentioned, and the here is where you can actually add metadata about your event. So it can be like, you can add query parameters, you can add headers based on whatever you wish to monitor. Now, in order to run this, basically all you need to do, as I mentioned, is to start your Spring Boot app. So for that, you could start the recording using the same command. So this will basically start the Spring Boot application. Now, once the Spring Boot application has been started, you could now see that it is running. So you could go in the browser and start hitting your endpoint. So once you're basically passing that query parameter as a part of the URL, you would see that this parameter is now being captured. So I have added a sample log to just help you understand that the endpoint has been invoked, and this particular query parameter will now be a part of the recording. So how do I actually view that is using the subscribe thing. So the subscriber basically is going to subscribe to this event. So what I need to do is that the Spring Boot application will be running, and now basically I'll be subscribing to that event which has been occurred. So in this case, what I'll do is that I will just print the value of the query parameter which has been passed. So again, I would run the program, and you can see that it is now listening to the HTTP event stream. So now if you try to basically run again, hit the same URL by passing, say, a query parameter, say test, now you can see that it has been invoked. So you run the particular you run the query, and then from the browser, and you can see that the log has been printed. And in addition to that, you would also see that it has been logged into your console, which is basically indicating that this is the parameter that has been passed. So this is a simple example, but you can actually extend it based on your project requirements, where you can actually have multiple scenarios on how to identify these endpoints, how to monitor these endpoints, and how to detect any memory intensive task in your particular RESTful application. So this is more or less how this event streaming API is working. So in conclusion, I would like to say that yes, choosing which method or choosing which approach is something that you would have to take a call yourself, because based on your requirements, you would actually have to decide whether you want to go for a Java flight recorder, or you would actually like to continue with the logging API itself. But when it comes to identifying performance bottleneck, I would rather recommend using the JFR, because then in the long run you could actually leverage it, and it is going to be there is a lot of more enhancements that is happening in this area. And finally, these are some of the references based on which I created my presentation today. And once again, I would like to thank the entire team of the JConf Dominicana for again putting up this wonderful event, and for giving me this opportunity. So thank you, and gracias.
Great, great. Thank you so much, Karen. It was impressive. The JFR is an incredible feature. Surely an option. That was amazing. Thanks for sharing with us. Thank you.
Thank you. Thank
Yeah.
you. Bye bye.
Wait, we have a couple of questions before you
Yeah.
leave.
Okay.
So one of them is difference between Java Flight Recorder and Java Mission Control.
Okay, that's a good question. Now, the Java Mission Control, as I mentioned, it is a graphical user interface. So all it would do is that it could take in as an input the Java flight recording, and it would display to you all the parameters of your recording. So it is more like a visual thing. But in case of a JFR, you can actually leverage the APIs. You can write your own programs, and based on that, you can monitor those events or record those whatever information you want as a part of that. And that would the output of that would be a JFR file. So it's like two different things, but then you could link it using, the JMC, Java Machine Control.
Yeah. Great, thank you. Another question is the difference between Java Flight Recorder and an application performance monitoring app.
Okay, so the application performance monitoring app would it depends on if it's based on like what kind of information are you monitoring, because in case of the Java flight recorder, since it's an event recorder built as a part of the inside the JVM, it would try to record all the events that is been going on inside the JVM. But if it's going to be just application monitoring, maybe it would not be able to extract all the vital information like say CPU usage or heap usage, etc. Maybe that would be just like simple like a general monitoring. But if you have to do in-depth monitoring, maybe you'll have to use the JFR in that case. So maybe that depends on the level of monitoring you would require actually.
Excellent, thank you. And our last question: can I improve the usage of my application garbage collector based on JFR insights? How can I troubleshoot my garbage collector performance using this tool?
Yes, exactly. So I mentioned that JFR has a lot of features to offer, one of which I have touched upon, which is the event streaming, although that is more for microservice kind of application. But there are other features where you can actually leverage like dynamic. I mentioned about custom events and those kind of things where you could actually do a lot of stuff where you can monitor, you can do garbage collection, monitoring, etc. Everything which is possible. There is something called as periodic events as well. So all this is going to help you for garbage collection, monitor the garbage collection, and it was built mainly for this purpose only. So the main idea of the JFR is to do profiling, to do garbage collection analysis, to do even black box analysis as well. So this is the main reason of using JFR. So that is something that you could easily leverage. Only you need to basically go in depth of that topic. So maybe that would be another session in that case. Yeah.
Oh, that's great. That's great. Thank you. Welcome to JConf Dominicana, to the Java Dominicana community. We hope to have
Thank
you in our further events. So, yeah, you're welcome. And to let you
Thank
know,
you.
before your session or your talk, 82% of the people didn't know about the JFR, and now the ones that do are sure are going to use them in their applications. So, yeah, we got it
Great.
there. Thank you, Karan.
Thank you.
Gracias a
Thank
todos.
you. Thank you so much. Have a nice day. Bye-bye.
Take care of yourself. Gracias a todos. Quédense que ahora vamos a la siguiente charla. Nos van a llevar, así que nos vemos unos minutos por allá.